All right, let's look at the inverse matrices. There's an interesting way to find the inverse matrix using cofactor matrix. All right, so let's look at that. All right, A inverse. So inverse matrix can be found by taking the transpose of cofactor matrix, then divided by the determinant of A. Right? Let's verify that this will actually give us the inverse matrix. So let's try to verify. So let's check. Show that if you multiply A inverse and A, we'll get an identity matrix, which means that you have ones on the diagonal and everything else is 0. Right? So let's do that. So if you look at the A inverse A, it's going to look like this. So A inverse is a 1 over determinant of A. Then you have transpose of cofactor matrix, then times A. Alright, so to make our lives easier, maybe let's look at the ith row jth column element of the result of this matrix. So I'm gonna use this notation. This is the ith row jth column element, right? So here, so we take the ith row and the jth column element. All right, so let's write it out. All right, so it's a 1 over determinant of A, and a cofactor matrix looks like this. C, so it's a transpose, so it's going to be a C1, 1, C2, 1, and so on, and a CN1, and a C1, 2, and so on, C1N, right, CNN, right? Then multiply by matrix A. So it's A 1 1, A 1 2, and so on, A 1N, A 2 1, and so on, A N 1, and so on, A N N, right? So it's a little tedious. Then we're going to look at the ith row and jth column element. All right. Then since 1 over determinant of A just a constant, so I'll pull that out. So it's going to be 1 over determinant of A. All right. So in order to get the ith row jth column, we can just look at the, say, ith row, which is these guys, and starting with C1, C1I, and C2I, and so on, and CNI. Right, and the jth column, so jth column would be these guys, which is going to look like A1J, A2J, and so on, ANJ. Right, so if you multiply together, you're going to end up getting this summation. All right, so it's K goes from 1 to N, and it's going to be, I'm going to write these guys first, A, KJ, and times C, K, I. All right, what kind of number are these? All right, so if if I and j are equal to each other, right? Then you can see that you know, this is the definition of determinant. It's going to be exactly like, so if I equal j, you're going to get exactly like this, because instead of I, we put j there, right? Which is just a definition of the determinant of a. So you actually get the determinant of a. So it's a 1 over determinant of a times determinant of a, which is going to be just 1. Right? Maybe maybe I'll just put 1 here. So if I is equal to j, then we get 1. Right? If I is not equal to j, you notice that you are multiplying a wrong row. In this case, let's see, maybe I should say wrong column. So it's equivalent of having the repeated rows or repeated columns. So if you take the determinant of that, it's going to be 0. So it actually gives you 0. Right? So it tells you that if row number and column number are the same, you get 1. And if they're different, it's 0. So you can see that, so therefore, A inverse A is going to give you, so if row number and column number is the same, which means that they are diagonal here, and everything else is 0, which is the identity matrix. Right? So if you want the if you want the inverse matrix, we can find it by take the transpose of a cofactor matrix, which is not that easy to find, then divide by the determinant of the original matrix. Right? That's it. I hope that this was clear.